So this session is now being recorded. The topics for the next hour is an overview of the Predictor-LimA software suite. Especially I will go into the new portfolio of the version 2019 that has been released in November last year. Then I'll go into Predictor 2019, give you a short overview, give you an overview of the new and improved functionality, and I'll show you the changes in the version 2019.02 that has been released just last month. And then I'll go into some demonstrations on emitting facades and emitting roofs, as well as moving sources. And we'll see, maybe we have also some time for questions, and questions can be put using the chat option. And I will monitor the chat, see what questions come in. So I'll try to handle them as they come in, but I also want to go through all the topics on this list. So Predictor-LimA software suite is of course Predictor, LimA, and Acoustic Determinator. Predictor, being a Windows intuitive, menu-driven software, uses the powerful LimA calculation cores, and Predictor supports about 20 calculation standards. LimA, of course, being the modular, flexible, and very powerful menu and command line driven software. So it also includes the LimA macro language, and LimA is therefore the preferred software for integrating noise mapping and large-scale data handling in GIS, GIS, and other web-based systems. LimA supports 30 standards. Acoustic Determinator is software for determining the sound power levels. So you measure a sound pressure level close to the source, and with Acoustic Determinator you can calculate the sound power level. Then this is the major change in the portfolio. November last year, we changed the number of configurations from 9 to 5, and we increased the functionality of every configuration. And you see that we have the Predictor-LimA Advanced, the Plus, the Standard, the Predictor Basic Plus, and the Predictor Basic Standard. If I start at the right-hand side, the Predictor Basic Standard now includes all predictor methods, excluding the Knossos. This means that if you look underneath this table, the predictor method now includes Knossos, ISO, NMPB, XPS, RMR, Harmonize, BS5228, the DAL, the Chinese HD 2.4, the American Traffic Noise Model, TNM, the Australian ENM Link, and the new Analyst module. Analyst replaces the separate Predictor Analyst software that's now integrated in Predictor. So you get all these methods, excluding the Knossos, in the Predictor Basic Standard 7810i. Then, if you want to handle larger models, you go from the Standard to the Plus size, and you can go into Predictor Basic Plus. Also all predictor methods excluding Knossos. We also increased the number of cores being supported, so you calculate faster. Then if you want to include Knossos, you go into the Standard that has all Predictor and LimA methods. So the Standard includes both the Predictor software as well as the LimA software. There you have all the standards, 30. And then if you want to have larger models, you go into the Plus. And if you want to have noise mapping, large-scale noise mapping, you go into the Advanced. You also have an 8-core support. So you see that there has been many changes in the portfolio. So we go into the Predictor software. Predictor, of course, has a fast learning curve. It has a very intuitive multi-model user interface, and Predictor, I would say, is by far the most intuitive software on the market today. It has advanced modeling options, detailed result analysis, integrated data and result management, and that's very convenient because with Predictor, if you see a result, it's always calculated based on the objects that are in the model. You cannot make a mistake. Like some other softwares, just keep the last calculated results, and you can change all your buildings, your sources, and the results stay unchanged. In Predictor, we think that's very not logical. So we want to match the results with the input data, and that's guaranteed in Predictor. Like I said, we now included analyst software in Predictor. It of course uses the powerful LimA calculation course, and also Predictor has a network modeling and calculation license included. So with one Predictor license, you can use Predictor on all your computers in your network, and you can start calculations from all your computers in the network. All calculations are automatically passed on to the calculation computer that has the HASP protection key. So looking at Predictor 2019, new functionality, like I said, the analyst functionality, it replaces the original Predictor analyst type 7813, and that allows accumulation of contours, different contours, noise exposure calculations based on demographic information. So you can count the number of people, you can count the number of dwellings within 5 dB noise classes, for instance. In that ISO, we have included now a new calculation setting for the valley correction for wind turbine. That's a method described in the Institute of Acoustic Good Practice Guide to the ETSU R97. Some new calculation options. We have modified the LimA Knossos. I will come back on that. Further changes are still to be expected. And a lot of other new functionalities like color-filled circles, color-coded result on the receivers, etc. I won't go into that part, but I will go into this part because we have released last month version 2019.02. And there have been some further improvements for the Knossos propagation, and that has been the German approach, because at the moment there are no official test cases for Europe for the Knossos. Only in Germany there has been development on test cases, and the LimA calculation method in the version 2019.02 fulfills all the 28 official German test cases. And it is not unlikely that these German test cases will become the official European test cases, but that still is not decided. So we have to wait. Then what we've also done is we added new indicative sound power levels derived from the BS 5228. In this method, a British standard is a long list of sources with a measured sound pressure level at 10 meters distance. And what we did is we calculated sound power level based on this sound pressure level at 10 meters distance, and then put it in the sound power catalog. So now you can choose between all those sources, and there are many sources I will show you later on. Then we have further extended the valley correction. You can now also select it for the general method of ground attenuation. Some printer setting option has been added. And some solved problems. In some cases, LimA Knossos could stop with the calculation. The table of wind turbine results did not show results, not so convenient. And in some cases, the export options were disabled. So those are the changes in version 2019.02. Then, before I start the demonstration, I want to focus that since the switch last year from Brø & Kjær to EMS Brø & Kjær, the support has been centralized worldwide, and that has been working very well. So you can send all your support and also sales questions to cms@emsbk.com. And if it's a support, and this help desk is handled 24 hours a day. So it means that you might not always get an answer within 24 hours, but it will be registered and it will be started. And within the soft noise company, we will get an email from EMS with a issue number, so we can contact you as a customer directly to handle the question. And that has been working very well. You can also use the menu option, help create support mail, and then you come in this option, and that gives us some more information on what type of configuration you are using. Also, if you have what license files you have. Also, what are your temporary directory, the Windows directory, etc. And those things can help us if you have some problems with the software. So that was the first general start. I'll just see if there have been any questions. No, no questions so far. So I will switch over to Predictor. This is Predictor version 2019.02, the latest version, and we're looking at a model, and that's part of the demonstration project that's integrated in Predictor. And what you see here is a model with 3 groups. I've got a distribution center group over here. I've got a oilco group over here. So in fact 3 companies, and I've got the warehouse group here. So groups are of course used for grouping sources. And many people I see in the models that many people use groups of other things, but I would not recommend that. Please use groups only for sources. So if I look at the group manager, I see that there are 3 groups. In the main group, you put all your buildings, all your calculation points, your grids, and in every group, you put your sources. Because the benefit of groups is that you can see the contribution per group, both in the contours and in the table of results. And that's the purpose of groups. So please do not use groups for anything else. You could also drag buildings in groups, but it has no effect. However, if you drag receiver points or grids in groups, then you restrict your calculation for the grid only to the sources in that group. And in 9 out of 10 cases, that's not your intention. So groups should be used for sources only. Hopefully that's clear. So, emitting facade. So I'm zoom in this part of the model, and let's assume that this building is becoming a new company on this industrial site, and I will take away my background map because it's more confusing at the moment than helpful. Let me just close this reminder, and now I can close. Yep. So, and also let's deselect the grid points in the display options. So now I've got a nice clean. I will zoom out and see the effect. So I've deselected the background map, and also I have deselected the showing of grid points in the display option. That's a more nice way of looking at your model at the moment. Such a background map is nice if you're entering buildings, you want to draw over the background map, or if you want to make a print output, but not while you're actually doing changes in your model. So suppose that this building, and this building is a building of 14 meters height. Suppose that this building is a new furniture company. They're creating and manufacturing furniture, chairs, whatever. And there's a row of windows at the right side, which can where noise can be transmitted through, and also through the roof. There might be some noise coming through. So let's first model the side, the windows. I go to the icon that represents the emitting facade, and I've got my icon bar over here, and of course you can put your icon bar everywhere, at the left, at the top, or beneath your model, but I usually have it beneath the model. So I click on emitting facade, and then my mouse changes to a crosshair. I also want to go and snap to the items, and I want to snap to distance of 10 centimeter, because an emitting facade is in fact a line segment. You enter it as a line segment that should be located a little bit outside the building. So you cannot position it inside the building. It should be located outside the building, an emitting facade. And you see that I'm now within snapping distance. If I move my mouse cursor close to the building, you see a small circle, and that means if I click now, this point will be automatically dragged to the distance, the snapping distance of 10 centimeter. So I move my cursor until I see a circle. I click, that's my first point, and then on the side I click again. So I've entered my emitting facade as a line segment at the moment. All other attributes are entered in the dialog itself. So let's say that these are windows, and an emitting facade is in fact a surface that is, let's say, attached on the side of the building. And you can here define the starting height of that surface. Let's say that the windows itself start at 1 meter from the ground. Then I enter 1 meter here as the starting height of my emitting facade. Then I go to the properties, and here I can give you the total height of my emitting facade. Let's say it's 5 meters height. It's, well, let's say 3 meters height. The windows are, let's say, 3 meters high. So it starts at 1 meter, and the total height is 3 meters. So the ending height is 4 meters of the emitting facade. Then here you have to enter the distance between the sources, because all sources in an ISO model, I've created an ISO model, are of course converted to point sources, because the ISO 9613 method can only handle point sources, not line sources, not area sources. So we have to convert all surfaces, all area sources, and an emitting facade is a kind of a area area source. We have to convert it to point sources, and here you can, as a user, you can define the detail, how detailed you want your point sources to be. So let's say every 5 by 5 meter gives you 7 sources, but let's say we want to have it really accurate, 1 by 1 meter. Well, that's a bit over accurate, maybe. Let's say 2 by 2 meter, and then I end up with 15 point sources. That's reasonable. Then you go into the emission tab. Here you can either enter the source power directly, so the radiated source power that's coming out of the building in a sound power per square meter, or in a total sound power. You can enter it here in these fields, or you do the indoor-outdoor calculation, and that's the one we're going to use. I click on indoor-outdoor calculation, and then you can enter the sound pressure level indoor. So here you enter the sound pressure level indoor. And let's say that there's a sound, I'm just doing a random figure here. Let's say it's an 88, because I type 88 so easily. 88 per octave, and that's a linear spectrum. And of course, as you all know, Predictor needs A-weighted spectra, so I need to click on the Apply A-weighting button. So this is now my A-weighted indoor noise level, a total sound pressure level of 95 dBA, a high indoor noise level. Next, I can select the insulation material. So I click on the catalog option, and here you see the isolation spectrums that you can select. Let's say it's an 8 millimeter single pane glass. Okay, I select it. So the insulation is now added per octave. Then you see that automatically Predictor has calculated the sound power level per square meter that's coming out of the building through the sources. There's one additional parameter that you can enter. That's the diffuse correction, and this diffuse correction is when it's very reverberant inside, it's almost 6. When it's not so much reverberant, it will be 3. So you can, for instance, use a 5 to be safe. I say OK. So I've now entered my emitting facade. And if you look at the 3D view, and I rotate it, you now here see the 14-meter high building, and you see that the emitting facade starts at 1 meter from the ground, and the height is 3 meters. And here these small lines is the lines to the point sources that are created. So you see now both the area source and the individual point sources. Well, the individual point sources might not be that good to see, but you know the meaning. And they are all nicely centered in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 point sources. Exactly what we saw when we entered the emitting facade, exactly what we saw here at the Properties step page, 15 point sources. Also in the 3D view, you see the 15 point sources. Of course, the last step gives you the working hours. If this company is not active in the night, you can say 0 hour in the night. And if it's only 2 hours active in the evening, you can say 2 hours in the evening, etc. And of course, the periods can be set with the in the model menu, period definitions, and here you can define the times for the day period, the evening, and the night period. And if you only want to do the day period, then you can delete the evening or night just as you want. There's always a compound period which you can use. Per default, it says the LDEN, and the LDEN, of course, is the average of the day plus 0, the evening plus 5 dB, and the night plus 10 dB. And so here are your period definitions. So we've entered a new emitting facade. Then we also want to enter the roof as an emitting roof. So I go to the emitting roof icon, and I could actually do it differently. I could also select the building, say copy, then go to the right mouse click, say paste special, and say I want to paste it as an emitting roof. And then I've got exactly the surface of the roof. And I say OK. So now I've used the building, I copied it, and I pasted the building as an emitting roof, because then I have exactly the same surface. And now, of course, I need to change my properties of my emitting roof, and the best way to enter, in this case, an emitting roof, is to say that it's relative to the item directly below, because the item directly below is in fact the building itself, and the height relative to the item directly below will be 10 centimeters, because also an emitting roof should be a little bit higher than the building. If you put an emitting roof in the building, then the building will act like a barrier, and that's not what you want, because it's outside. So 10 centimeters outside. Here again, you need to give in the number of detail. Let's also say 2 by 2, 2 by 2 meter. So you've got 49 point sources on the roof. Same, we want to do an indoor-outdoor calculation. Let's say that again, the indoor is 88. It's the same sound pressure level we're going to use. And again, I have to apply the A weighting. And then I have to click on the insulation material again, similar. Let me scroll down. Let's see if there's something with a roof. I don't know, roof. Well, there's several. Of course, you can enter your own insulation material. Well, it won't be wooden border, whatever. Plastic, plasterboard. Well, cellular concrete. That's of course, that has a nice high insulation factor, but just for fun, we do a very low insulation. We do as it is a wooden boarding. Okay, well, it won't be a wooden boarding, but anyway, I've selected it, and then I say okay. Again, the diffuse correction. Let's put it on 5. Say okay. So I've entered my emitting facade and I've entered my emitting roof. If you want to get rid of all these point sources, you can go to the detail point sources in your display and deselect it, and now you only see the outer contours of the emitting facade. Now I go to the group manager, and then I'm going to create a new group because it's a furniture company. Furniture. Okay, and then I'm going to drag my emitting roof into the furniture company, and you also see that by mistake, because the active group was warehouse, and when you have a group selected here in the main speed bar, then all items that you're entering are put automatically in the group warehouse. So in fact, by mistake, if you click on warehouse, you see that the windows have been put in the group warehouse. That's of course not the intention, so I can simply drag it to the group furniture. But be aware that if you've selected an active group, that all new items that you're adding to your model will be put in that group. And you always need to check afterwards if it's okay. Personally, I think we should not do that. I will discuss it with the developers. Maybe we should automatically put all new items in the main group, but that's up for discussion. So I've created a group furniture with two sources. And this is, of course, the roof. And just going to give it the name roof. So you can also double click on items in the group manager if you want to change attributes. Okay, I close it. Now I'm going to start my calculation. Start calculation, all calculation points. Yep. Gives me a chance to take a sip of my coffee. Let me see. I also want to check if there are no further questions. And because this is, let me see, 9:45. I'm going to stop this one. I just want to show you a little bit less detail. I'm going to change the properties here. I'm going to give it a 25 by 25 meter. And then I'm going to restart my calculation. Because I'm running on a slower laptop, so I don't want to, the calculation takes too long time. So I've reduced the number of calculation points, but that is just for the sake of the calculation time in this case. So here you see the calculation progress during the calculation. You see that it will take maybe a minute or so. Always a small overhead when starting a calculation. So that gives you the time to put a question, for instance, in the chat option. If there are any questions, please use the chat to do so. Don't see any questions. Okay, that's good. So everybody understands. After the calculation, you can show the, I will deselect my snapping. I don't need it anymore. I can then select to show my contours, and I'm going to use default contours, the areas, etc. So what you see over here is the calculated contours for a warehouse, but of course I want to go to the main group. Here are the calculated contours for the main group, SDL then. I can also show them as day periods. Then the distribution center only are these contours. Allco, these contours. Warehouse, these contours. And the new group, furniture, these contours. So here you see the effect of the new furniture company. So this in fact, and if you go to the 3D view, you see nicely the emitting roof. And where's my emitting facade? Somehow my emitting facade has disappeared. I don't know why, but let me just check if I want to see. Ah, yeah, they are covered. Okay. Yeah. It's a good point because my contours are calculated at 4 meters height. And that's why I did not see my emitting facade, because the emitting facade starts at 1 and ends at 4 meters. So if you show transparent contours, then you can see through the contours and then you can see the emitting facade laying there. So if you go to the calculation settings, you see here that the calculation height for the contours is 4 meters. So that's why I didn't see it. There was a question. Let me see. Why LimA use another type model of plane sources. I do not understand the question. This is our own implementation of the ISO 9613, and so here we have chosen our own implementation of area sources, line sources, etc. And so I don't know exactly what the question is. LimA is a different software. This is not a LimA calculation core. If you have chosen a LimA calculation method, so if you chose a new method and you choose, for instance, the LimA ISO method, where is it? LimA ISO here, LimA ISO method, then the area sources are handled through the LimA implementation. But now we're using the ISO, our own DGMR implementation of both the DGMR implementation and the LimA implementation are quality assured. However, the implementation, of course, is different because they're two different companies. But if you have chosen the LimA ISO method in Predictor, then if you're using the LimA settings, then you can use the LimA settings. Okay, so these are my contours. Let me see. Yep, we have time. So the next I want to do is to enter a moving source. So I'm going to take off my results, hide contours and result labels. And let's say that there's also a moving source on the area of this furniture company, and there's a truck driving from maybe here to here all the time. So we zoom in and I click on and in this case, I could already select the furniture company as the active group because we're going to add a moving source that needs to be in this furniture company. So I click on moving source, and again, the snapping option is still active. That's good. I can also deselect the snap. Let's say I don't want to use the snap anymore because I just want to enter it here. And let's say there's a truck driving all the way, all day, moving whatever stuff from this side to that side, just for fun. So a moving source is a line source. In fact, it's handled as a line source. However, it has some very convenient attributes here in the properties. First, for a moving source, you have to give in the sound power level of one single source. And then in the properties, you can say how many sources there are, how many movements there are in a day, evening, and night period. So if I go back to the emission, I have to enter the power level of one moving source. Well, I can open my sound power database, and here you see some interesting things. What we've done, we've added the sound power level of a normal light vehicle according to the Knossos method, driving 50 kilometers an hour, a medium vehicle, a medium heavy vehicle driving 50, and a heavy vehicle, like lorries driving 50 kilometers an hour. Then for 80, the same, then for 100, etc. However, we've also added, like I explained, sound power levels based and derived from the BS 5228. And here you see the formula that we have used. We have used the sound pressure level at 10 meters. We've added 10 times the logarithm of 4p 10 squared minus 3 as a ground reflection of 3 dB. So that's how we derive the sound power levels. And then you see all the sound power levels for breaking up concrete, handheld pneumatic breakers, there are a lot of crushers, excavators, yes, loaders. So if I now say on truck, find next. So there are a lot of trucks, an articulated dump truck, a dump truck, a cement mixer truck, etc., etc. So there are a lot of sound power levels for trucks now added to the sound power database in Predictor, and that's nice to know. Let's say if we dump trucks on whole roads, well, I'm just going to select one. I mean, the idea is of course obvious. Let's say this is a very high sound power level. Ooh, that's a bit too high. Let me go to this one. It's also high. This is going to have to select a little bit lower. Okay, let's select this one. So I select this one, I say OK, then it's filled in, sound power level. Yeah, total sound power level of 107 dBA. I would expect a heavy vehicle driving with a slow speed, maybe to be that. Then at the properties side, I can now give it the velocity. Let's say that this vehicle is driving 15 kilometers per hour. And here again, you can give it the detail, how to divide up this line source into point sources. Again, with the spacing parameter. In this case, for example, 25 meters. Here you can get the flow in the day period. Let's say in the day period there are whatever 60 movements. In the evening period there are 10 movements, and at night this company was not active. And what you see here is a kind of a time correction in decibels, but the main thing you need to enter the flow, the speed, and the distance between the sources. Those are the interesting items, attributes you need to enter. So I say OK. So I've added my my point source. Again, if I click on detail point sources, you see also for these moving sources where the actual point sources are located. And you see that if you, for instance, have a calculation point nearby, you might have a higher, a smaller distance between the sources. But normally the nearest buildings are far away anyway, and this is good enough. Then we're going to do a calculation again. And in this case, let's say, okay, going to do the start calculation again. And I would assume that in this case, yep, okay. So time for questions. It's always nice that we have some time for questions when the calculation is running. How many point sources do I need? What did I say? How many point sources I need? And make bad noise contours in west facade. How many point sources? Okay, there's a question on how many point sources do you need to split up a line source or an area source in order to have a realistic calculated sound pressure level? Well, as a rule of thumb, you look at the nearest calculation point. Let's say that this is the nearest calculation point, then the distance between the point sources should be smaller than half the distance to the nearest calculation point. And you see that if the calculation point would be here nearest, then this is detailed enough. So that's the rule of thumb. The rule of thumb is that you look at the distance to your nearest calculation point that's of interest. Of course, your noise contours are nice to see, but the real issue, of course, is the sound power level near the closest dwellings. So these points are the most important points. So here your calculated level should be accurate. And this means that if this is the distance, it's a long distance. So the distance between your point sources should be smaller than half the distance to the nearest calculation point. And that of course is perfect here because it's a smaller distance. So, but of course, if you want your noise contours to be accurate within 1 meter of this building, in fact that's impossible because the ISO 9613 method is not that accurate. But if you want to do it calculation-wise, yeah, then of course you have to select 1 meter between your point sources. That's obvious. So yeah, you have to be practical about it. It's an empirical method. The ISO 9613. It has many limitations, and I think Predictor handles these limitations very good. And so yeah, that's the idea. Okay, so let's go to the contours again. And now you see that this truck has a kind of a big impact because it was a quite large, high sound power level, and there were many movements in the day, evening, and night period. In the day period especially. So because if you go to the night, then of course you see nothing because the night. Did I give a night value? Let me see. No night. Maybe for the work. The roof. I forgot to limit the roof. So the roof is still active in the night. So these are the night contours only for the roof, for the emitting roof. So that's the emitting facade, the emitting roof, and the moving source item. I'll just see if there are other questions. Otherwise, I would like to show you another option of Predictor, the analyst option. That's a nice option to show. But I'll just wait and see if there are any questions using the chat option. I missed what BS5. Yeah, no, just let me check. There's a question coming in. Oh, there's another question. Can I use noise emission direction characteristics in movable sources? No. Moving sources are omnidirectional. So with a moving source, at least, is it true? Let me just check. Yeah. No. So a moving source is always omnidirectional. There's no additional directivity. Then I missed what BS5 5228 is when you were talking about the sound power of moving sources. Yeah. Okay, so let me just double click on a source and go into the sound power level. So the BS5228 method is a calculation method for how do you call it? Encampments, sites. I forgot the word about it. At least it's a British standard for noise calculations according to heavy material, like breakers and pulverizers, hydraulic breakers. And in this method, there's a long list of sources with a sound pressure level at 10-meter distance. What we have done, we've took this list of sound pressure level on 10 meters and we calculated the sound power level with this formula. The sound power level is the sound pressure level at 10 meters plus 10 times the logarithm, the 10 log of 4p r squared, and r is of course 10 meters minus 3. So with this simple formula, we have now created an indicative list of sound power levels of many types of sources. All sources, wheeler loaders, vibration rollers, pilings, etc. So this is a convenient list of using when you are searching for that type of sources. So now this sound power catalog that's included in Predictor not only includes the original list. Go to the down. The original list of the Imagine European Working Group, the source DB sound power levels, that's also in this database, but also the 5228 sound power levels, and also the sound power levels of road traffic noise according to the Knossos method for light, medium, and heavy vehicles. So it's now a very convenient list of sound power levels. If you don't have your own sound power levels, this is now a nice list to use. So hopefully that is the answer to your question. Let me see. For long distance, I can see one point source with all acoustic power. For long distance, I can see one point source. Yeah, that's true. If you, yeah, that's in fact true. Of course, if you go further away from any source, then at a certain distance, you can consider all these sources maybe being one point source, you know. But of course, because there is shielding, there is barrier attenuation, there's of course a strong directivity due to reflections and barriers. So that's why you always need to do them as individual sources. But if you could measure the complete furniture company at a longer distance, then that's a very accurate way of calculating the sound power level in that direction. And so that would be a good way. Normally that's not possible because you have all kind of background noise. So you always need to be closer to the source anyway. So hopefully that's the answer to the question of one point source. Okay, then the B is 5228. Yeah, okay. I think I've handled all questions. Just check. Yeah. Okay. So for the last part of this session, because we've got some time left, I would like to show you very quickly the new analyst method that's included. And we've got some analyst method here. Yeah. Okay. Wooden. Yeah. Okay. So in this case, I'm going to the, let me see, example models, city noise map. Okay. Yeah, an analyst. So I'm going to create a new model, and that's this model, general analyst, and I'm going to do the cumulated road plus rel. Oh, sorry. Cumulated road plus rel. Okay. So I've added this one, and what I want to do is I want to use the contours in the rel and the contours in the road model, because let me first open both models and then put them next to each other, and then result. Oh, why is this? That was not the initial model. This is not the one I meant. I meant that's the rel. I meant this one, because that's a road model. And then tile horizontal again, and now do my contours. And I'm going to take off my background maps because I don't need them. Upscale, okay. And that was an online background map. So this is also real. Yeah. True. Yeah, then I need to go to the road traffic city noise map of Woerden and the road. Yeah, sorry, I made a mistake. So I needed a road traffic noise method, and then I'm going to tile them again, and then I'm going to show you the contours. And of course, all these labels is something I do not want to use. Let me see. I'm going to do my default settings, and I do not want to show my grid points. Okay, so here you see the road traffic noise model above, and below you see the real traffic noise model. And now I want to make a cumulated model. So I'm going to open my analyst model that I've created here, the cumulated road plus rel. And here at the right hand side you see a new a new sidebar. So next to the selection, display options, for an analyst model, you also have the analyst sidebar. And now you can import data set from existing models in your project. So you click on import data set, and then you go to the road traffic city noise map, and you go to the Woerden, the one that I also have open, the NPB 2008 Woerden. And here you can select what do you want to import. Well, counterpoints and grids for day, evening, and night. Yep, that's good. You see automatically here a tree is built for day, evening, and night. And now I click and you see the outer contours, the outer boundaries of all your calculated contours. Then I do the same for the rail traffic. I go to rail traffic, city noise map, and I do NPB 2008 rail. Again, counterpoints, grids, day, evening, night. And here you see the outer contours of the rail traffic noise model, and those were smaller than these ones. If you have calculated data from another software, from CADNA, from Soundplan, Lima, whatever, you can simply import them also by either using shape import or text file import. So you can actually cumulate all different type of files here. Okay, you see that automatically the tree has been updated. You see for the day period, we've got road traffic and rail traffic for the evening and for the night. Now, we have to go to the result. We have to go to the analysis, result contours and result labels, this option contours and result labels. And here we have to select what type of cumulation do we want. Well, I would like to have the LDEN cumulation. So I click on this one, the LDEN cumulation. I say OK. And now when I click on the upper level of this tree, this is a kind of result tree, I see the cumulated levels for the LDEN period, for day, evening, and night, for road, rail, and road and rail traffic. You can also add industrial noise or any other models you can add to the tree. And if you want to focus, you can also create a focus area. And a focus area, that's interesting, if you import a shapefile, for instance, because I've got a focus area here. Let me see if I can find it. Data. Was it here or not? I'm not 100% sure. Examples. No. Where was this? I forgot where I put it. So many DXF predictor projects. Ah, yeah, now I know. It's in the documents. Predictor demo. Analyst example data. Yeah, that's it. So there's a center border shapefile, and I want to import that as a focus area. So this is the center border as a focus area. And when I've selected a focus area, that means that automatically Predictor will cut away all other contours. So if I go to the contours again, okay. This takes, of course, a while because he has to generate all these grids. And you see that everything is away outside the area. And then if you also do not show the point data sets, then you've got a nice view. And then, as a background map, I could also open, for instance, the zip code point file. The zip code point file. And I think I have to put that on top, otherwise I will not see it. And you see all these small dots are zip code points. And now I can analyze my contours by clicking by confronting it with this zip code point file. And I can now calculate the number of dwellings inside for every zip code point. So now it's calculating the number of dwellings. So now you see that within B noise classes, the amount of dwellings based on all these zip code points that I've selected. You see all these zip code points. So this is an easy way of calculating the number of dwellings or the number of people, because in the same shapefile, also demographic information for the number of exposed people was included, or the number of people. And now we create the number of exposed people. So here you see the number of exposed people in 5dB noise classes. And this type of information is needed for the European noise maps. So this concludes my short demonstration of the analyst option. Hopefully you found it interesting. Let me just check if there are other questions. We've got a couple of minutes left. Are there any questions? Okay. Well, then I would like to thank you for your information and for your time and your attention. And yep, thank you. I hope you found it interesting. And there will be similar sessions during this year. So be aware, you will be informed by EMS. Thank you very much. I'm going to close down the meeting.